All right. So today we are going to talk about the composite functions, where we'll be combining multiple functions, and then after combining multiple functions, we'll have one single function for the combined one. So look at how that works. So first of all, let me remind you that we have the domain and range for each and every function, right? So we know how to get the domain and range, and we also know how to write those. So for an example here, this is a formal step of how to get or how to know the domain and range of a function. So far what we did was we tried to draw the graph of a function, and then from the graph we assumed, or we tried to guess the ranges and the domains. Okay. Now this is like an official step, like formal. So without even knowing the graph or drawing the graph, you will be able to find the domain. So for an example, look at the. So if you look at this function here, so what we are doing here in the function. So all we are doing is, let's say, if a function does not model some data or verbal conditions, its domain is the largest set of real numbers for which f of x is a real number, right? What I'm saying, what we are trying to explain is, so for each and every function, this has to be valid. For an example, let's say for each and every x, if f of x is defined, okay, that means those are the domain you are considering. Let me give you a very simple example. For an example, let's say you have a function like this, which is 1 over x. Now, if you plug some value of x here, and for those values, if you get an f of x, those are the valid values of x for which f of x is also valid. Now can you guess right away some value of x for which f of x is undefined in our function? How about x equal to 0? Can you find f of x here if x equals to 0? No. That means x equal to 0 is not the domain. It does not belong into the domain, because for that point we don't have the range, right? Because since you don't have the f of x, that means there is no range defined for x equals to 0. That means x equals to 0 does not belong to our range, to our domain. Okay. Similarly, what we do is domain is the largest set of real number for which the value of x, f of x, is a real number. So for any value of x, if f of x is a real number, that must be your domain. Okay. We exclude from a function's domain's real number that cause a division by 0. You see the example we have. So if x equal to 0 in our example, in our f of x, which is 1 over x, is undefined, which is again division by 0. So we always exclude that, and also the real numbers that result in a square root of a negative number, because any square root of negative number is also a types of number which are called complex number. I'm not sure, have you ever heard the name complex number? But the complex number is something
which does not belong in the real number set. Okay. In general, all the real numbers, we know what it is, like 1.5, 1.752961, doesn't matter what it is, we can imagine and we can imagine the graph or the plane. Okay. But anything, whenever you have something like you are trying to do a square root of a negative number, for an example, the square root of -3. If you try it in the calculator, you'll see the calculator will give you an error. Okay. But
But one way of solving this kind of number and getting an answer is called complex number. So the complex number is out of the scope of this class, so I'm not going to that direction. But what I'm saying is that there is a way of finding square root of negative numbers. But the only reason we don't include those is because the complex number does not belong to real number set. But the vice versa is true. All the real numbers belong to the complex number set. That might be a different discussion. We're not going to that point. Now, so here, now the first concern is how we can, let's say here, we can find the domain. Now look at the function. For an example, the function is 3x plus 5 over x squared minus 4x minus 5. Now just by looking at this function, we don't know anything about the domain, right? So now what we can do to know it. Now the step one, we always want to make sure that the denominator is not 0, right? Because anytime your denominator is 0, that means fx is undefined, or g of x is undefined here, right? Excuse me. So g of x is undefined. So we first want to know for sure that for which values of x this term gets 0. Because if x squared minus 4x minus 5 is 0, that means g of x will be undefined, right? So we always want to know for which values of x squared minus 4x minus 5 becomes 0. To do that, what we did is we assigned this value to 0. Now this is an equation, right? And then we will try to solve the equation. We know how to solve the equation, right? There are 100 different ways of solving equations, but there are some basic steps which we follow to solve an equation. Now why we need to solve the equation? Because we want to know what is the value of x for which x squared minus 4x minus 5 becomes 0. So that's why we want to know the value of x for which this term becomes 0, because we know that if this term becomes 0, g of x will be undefined. And we would definitely want to exclude those points. Now to exclude some points, you need to know the points first. Then you will say, okay, this point is excluded. Okay, that's exactly what we are doing here. Now to solve this equation, do you know how to get from here to here? Okay, I think we have seen something similar in DSPM 850, but let me show it you again so that you will know how to solve this part. I think there should be something there. Now let's say this is an equation. Now what we need to do is, this is called middle term factor. Have you ever heard it? Okay, let me remind that. So how we do is, for an example, we assume there is a 1, right? Okay, now first of all, we multiply these two terms, this term and this term. We multiply these two. What do we get? Minus 5, right? Because it's 1 and minus 5, so we get minus 5. Now, so what we do is we just write this 4x, okay, such that if you do the addition and subtraction, it will be always minus 4. But since you have 1 here and 5 here, these are two terms, right? Which is what? 5 terms, 5 times 1, right? So we want to get a 5 term and we want to get a 1 term like this. Let me write it first, then you will understand it better. Let's say I write like this. Look at this. Look at how I wrote. Look at what I did. I wrote 1 minus 5 and 1 plus 1. At the end it becomes still, do you agree? It's still minus 4. But what I did is 5 times 1, right? The reason I did that, because I tried to write it in a factor of 5. Now what are the factors of 5? You know, any number can be broken into factors, right? For an example, 6. How you can break 6? 3 times 2, right? for an example 9. How you can break 9? Several ways. 3 times 3, 9. 9 times 1, 9, right? Similarly, how you can break 5? 5, that's exactly what I did. 5 times 1. Do you see it here? But at the same time, I try to keep the positive and negative sign such that when you do the addition subtraction, you get minus 4x. Do you see what I'm saying? Look at this. When you do the addition subtraction, you still get minus 4x. But I just wrote those as a factor of 5. Now, when you have, because since you have multiple options of factoring, you might have, like, for an example, for 6, okay? For 6, you can write 3 times 2. You can write 6 times 1. Okay? So you can choose either one. Okay? But for 5, at this point, we have just one choice. So we just wrote that, which is 5 times 1. But you can choose either one, but there is still a trick. I'll tell you later. I'm not trying to confuse you at this point, but just stick with this, that we just multiply this first and we get a number. For an example, that number is minus 5, or let's say absolute value of that number is 5. And then we write these two numbers such that the coefficient of these two numbers is basically the factors of 5. So at this point, we are just writing 5 times 1 because that's the coefficient, the factor of 5. But when you have multiple options, like for an example 6, you will have multiple options because either you can write 6 times 1 or you can write 3 times 2. For 9, you will still have multiple options. So you can either write 9 times 1 or 3 times 3, right? For 18, plenty of choice. You can write 3 times 6. You can write 6 times, for an example, 6 times 3. You can write 9 times 2. You can write 18 times 1. All these are different options you have, okay? But you have a specific choice. I'll tell you later why you choose one. Now, for these options, you just have one option, so just forget about that. Now, let's do the next part. For the first two, I'll basically take a common factor. What is the common factor I can choose? What is common? X, right? So I take x as a common factor. This becomes x minus 5. How about here? I take 1 as a common factor because, you know, when nothing is common, 1 is common for sure, right? For between any two terms, you can take 1 as a common factor. Now, the reason I did this, now look at this carefully. Both of these terms has to be matched for sure. Since they are matching, you will write x minus 5 times x plus 1. That's how you can basically write any algebraic expression into multiple factor. Now, these are two different factors of this original equation. I'm talking about the left side. That's what I'm saying, expression. So this is the expression. Most of this expression, except some exceptional cases, most of the expression you'll be able to write in different factors, multiple factors. Now, why you need the factor? Because when you try to solve the equation, you need the factor because when you divide something into factor, you know this. For an example, this time this equals to 0. Now, what is true about this? When two different things multiplied and the answer is 0, you know one thing, that either of those two terms is 0 or both. Because if, let's say you multiplied x and y and your answer is 0, what does it mean? It means either x or y must be 0, otherwise the result cannot be 0. Because when the result is 0, that means one of those must be 0 or both of those are 0. Okay? Now, based on that, we would tell this. Either this one is 0, that means this. What does it mean? Right? Or this one is 0. So that means x equals to what? From there, we know that equals to 5 or for x equals to minus 1, this expression becomes 0.
That would exactly come up with that. because we assume that this expression is 0 and we have this answer. Now we know that for these 2 points, this expression becomes 0. Okay? Now, when we define the domain of this expression, we know that these 2 points must be excluded from the domain set, because if they are included, what happens? For those 2 points, this expression becomes 0 and your function will be undefined. You see what I'm saying? And that's why look at how they define the domain. They said they're trying to exclude -1 and 5, right? And then everything else is included. You see what I'm saying? Everything else between -infinity to positive infinity are included, except those 2 points. What are the points? -1 and 5. Now how you write it? You will first say, okay, we take all the points from negative infinity to, but what do you think? Is -1 included? Remember the brackets. -1 is not included because we cannot take -1, right? But we can take everything just before -1 and we can take everything just right after -1, right? So again we started from just right after -1 to all the way to 5. Is 5 included? You see the 5 is not included because we know that we cannot take also 5. Again we did this. After 5 we can take everything else. So look at carefully. We are basically taking everything from -infinity to positive infinity except 5 and 2. Now at this point I think we understand this, except I'm not sure whether we understand how we did this, but there is another way. I think we know this, but let me remind it for sure. There is another way of, there is a formula. Using the formula, you can right away find the value of any standard quadratic equation. This is a quadratic equation, right? Whenever the power of x is, it's a quadratic equation, there is a standard formula. Instead of, for an example, let's say you don't know how to get the factor, or something happened, or even if you know, you probably could not find the right factor. Forget about that, just use the formula. Anytime you need this, just use the formula. Let me write the formula, because I tried to do that because it's already given in the factoring format, but we can still use the formula. So this is a standard quadratic equation, right? We have seen it before, right? I'm sure we have seen this. Sometimes people write in capital A, so it's capital A, capital B, and capital C. It depends on the literature, or based on the book, it's a little bit here and there, but just assume that A, B, C, all of these are real numbers. Okay? For any equation which is quadratic, A must not be 0, because if A is 0, x squared term will be gone, right? Cannot be 0. So let me write it here, that A is not equal to 0. Now, there is a formula, so if you just try to keep it in mind, so you'll be always able to find the answer, x equals to what, just writing the formula. So the formula is this: x equals to minus b plus minus b square minus 4ac over 2a. Okay, remember this formula will give you two values, right? You saw the answer here. There are two values. When we get the two values, you know that, right? C is the x square. Any expression where the maximum power is 2, maximum power of x is what? There will be two value of x. If there is an expression with maximum power of x is 3, there will be 3 answer. I'm saying there will be 3 solution. If x equals to 4, there will be 4. But at this point, we are just talking about 2. There will be 2. Now, how you will get 2? From one equation, one answer. Do you see this plus minus? So just taking this as a plus, you'll get 1. Taking this as a minus, you'll get another.
Let's check whether we get the same answer from the other equation. Let's see whether we get there. Now here for our expression x squared. Now what is b here? What is b? -4, right?
So let's write -4 for b plus minus
b square is -4 whole square minus 4.
What is a here?
Is 1, right?
What is c?
-5, right? The c is -5. Make sure you match and you understand why we are taking it.
Okay. And what is a again?
2a, so it's 1.
So 2 times 1. Now let me write it again with all those cancellations. It's 4 plus minus square root 16 minus or plus 20. It's plus, right? Minus, negative. It's plus. Divided by 2. Now let's write it again. 4 plus minus 36 over 2. What is the square root of 36? 6, right? 6. Now let's write 6. 4 plus minus 6, 2. How much you will get? When you have a plus, it will be 4 plus 6, 10, right? Divided by 2, so that will be 5, right? When you will have minus, it will be 4 minus 6. It will be -2, right? Divided by 2. Do you get the same answer? So I think it's pretty much easy. So, you don't have to think about the factorings. And it applies to almost every single quadratic equation. So you can use it anytime you want to solve any quadratic equation. Just remember that. And now, remember, it's a little bit tricky and different in function to function. So the first function, we got that information that which domain points, which points are not included in the domain from that solving that equation. But how about this? Whenever you see this, for an example, how do you know exactly what points have to be excluded? Look at the function carefully. There is a square root, right? Remember what we said. We exclude two things. One is we cannot have anything any division by 0, right? We also cannot tolerate anything like a square root of negative number, right? Now, since there is a square root, there is a chance that for some value of x, there might be a square root of negative number. For an example, just to be simple, let's say x equals to 1. What do you get? If this x equals to 1, what happens? This becomes 2 minus 5, right? How much it is? The square root of -3. Do you know the answer? Nobody, except if you go to the complex number. There is no real number for a square root of -3, right? So we are almost sure that 1 is excluded. You cannot take x equals to 1. But how do you know which points? Because you have to know every points. So one of the ways, because you want to make sure that 2x minus 5 is always positive or 0. It cannot be less than 0, because if it is less than 0, it will be negative, and you will be ending up with a square root of negative number, and you don't want to do that. You cannot do that for sure, because otherwise it will be undefined. I'm saying undefined real number. Now, that's why we try to see for which values of x this part here, 2x minus 5, is greater than 0 and greater than equal to 0.
Remember, this is still an equation, because in an equation there can be inequalities as well, in addition to equal sign, because most of the cases we have seen the equation with the equal sign, but in any equation you can have inequalities. So this is an inequality. So, but most of the cases we solve in the same way, except when we multiply the both side by negative sign. Okay, we'll show you some example, but we want to know what is the value of x, right? So that means we want to isolate the x. What is our option? We first try to
Get rid of 5, so we added 5 both sides. Once we have 2x and divided 2x greater than or equal to 5, we divide both sides by 2 to get rid of the 2, and then we end up with x equals to greater than or equal to 5 over 2.
Now what does it mean? It means that for this value or more than this, we will not have any negative number square rooted, right? We will not have any value square rooted, okay? And that's what exactly we did in the domain. Look at this. We said that the domain will include this point and every single point larger than this, right? Look at this. What we said, starting from this point, including this point, we are taking all the point all the way to the infinity, positive infinity. Because everything can be included except all the points which are less than this, because which are less than 5 over 2 will give us negative square root of negative number. So that's what we were looking. So because whenever we'll see some equation, we'll do some math like this, and then we will try to find the domain set of that. So for an example, some of the domain sets are given here, because for none of these, one of the good thing is, for none of these equations or functions, we will not have any chance of getting division by 0 or getting square root. Why? Look at the first equation. See, there is no division by x. So there is no chance that for any value of x, you will have division by 0. You see what I'm saying? That's why we are pretty much safe, and we have taken every single thing, all the real numbers, right? When we say negative infinity to positive infinity, that means we are taking all the points. Nothing is excluded. Same is for the next one. But for the last one, look at this one. We are still taking everything. There is a root, but that's not a square root. That's a cubic root. And then for the cubic root, we can tolerate the negative numbers. Because when 3 numbers are multiplied, answer can be negative, right? Similarly, for an example, negative 2. If you multiply it 3 times, you will end up with negative 8. Similarly, if you take a cubic root of negative 8, you will get minus 2. So there is an answer for the cubic root. So we don't have any problem with the cubic root. The only problem we have is with the square root. Okay? So for all of these functions, we don't even have to evaluate anything. We can just answer right away. Okay? How about this? There is a risk, right? Look at the denominator. 3x plus 2. So there is a chance that for some value of x, that will be 0, right? Can you find those value of x? Make sure, so we will first find those value of x, and then we will exclude those points from the domain of fx. Alright, so let's see for which value of x 3x plus 2 becomes 0. So 3x plus 2 will be 0. So 3x equals to negative 2, right?
and then x equals to negative 2 over 3. Now remember, this is the point for which 3x plus 2 will be 0. So this point must be excluded. Now how do you write a domain excluding this point? You will start from negative infinity, right? And you will go all the way to this point, but you will not include this point. Look at this. We are not including this point. And we ended just before this point. And then we will again take all the points just after this to all the way to, so this should be your domain, right? Look at this carefully. We are taking every single point except negative 3 over 2. I'm sorry, negative 2 over 3. Any confusion or question? Oops. Do you think there might be something which will put you into trouble? Do you see the square root? We know there is a trouble because there is a square root and there might be some value of x for which 4x minus 1 will be negative. And when the 4x minus 1 will be negative, your function will be undefined because there is no real number for a square root of negative number, right? If you are taking a square root of negative number, there is no real number. Now, so what you are going to check? You are going to check that for which value of x your 4x minus 1, oops, your 4x minus 1 is going to be greater than or equal to 0. Because for this point you are trying to include, everything else will be excluded. Because we don't want any value of x for which 4x minus 1 becomes negative, right? Because if 4x minus 1 is negative, we cannot take a square root of negative 3 and get a real number. Now let's try that. So it will be 4x, I'm sorry, so 4x greater than or equal to 1. So you will have x greater than or equals to 1 over 4, right? So what it tells you, you take every point starting from 1 over 4 to positive infinity, including that point. So that your domain will be this: 1 over 4, comma, positive infinity. Oh, I'm sorry, this is open. So you are taking every single point starting from 1 over 4 to infinity, including 1 over 4. Because you see, it can be equal, right? Or greater. So you are taking that point, everything after that point, all the way to infinity. But nothing less than 1 over 4. Because if you take anything, because we can tolerate 0 as well, because we know that the square root of 0 is 0, so we can take 0. So if you have x equals to 1 over 4, it will be 0. Which is fine. We cannot tolerate negative numbers, but we can have 0. It's fine. Any question? All right. So let's see whether these are some algebra of functions. By algebra of functions, we mean that what kind of operations we can do between functions. For an example, let's say in general algebra between variables, we can do addition, we can do subtraction, we can do multiplication, we can do division, we can do many other operations, right? Like absolute function, absolute value of something, or square root, cubic root. We can do a lot of stuff like that. Now, for functions, for an example, let's say you are given two functions. Now somebody can ask, can we add two functions? Can we subtract? You see what I'm saying? So that kind of questions we are trying to answer here, that what kind of operations are possible between two functions. So here we have 4 lists. Now number 1, you can add 2 functions. Remember, when you are adding 2 functions, you will end up with one another new function. Okay? But how do you write it? In algebra, we write this way. For an example, you have one function g and one function f. Let's say you are trying to add. So either you can write f plus g of x, or, so that's how you basically will write, but that means basically you are adding 2 functions. Straight addition. You can subtract. Similarly, you can take the product of a function. Okay? That's a little bit tricky. You can just multiply. Look at how we are writing them. Okay? You are just multiplying 2 functions. You can take a quotient of a function as long as the function you will have in the denominator position is not equal to 0. Okay. So you can divide the function. Let's say you can divide f of x by g of x if g of x is not 0. Anytime we just always, when we do any kind of division, we always want to make sure that it's not a division by 0, because that is not defined. So we always want to exclude that. So it's almost pretty much simple, but whenever you are doing this operation, you know that f plus g will be the sum, f minus g will be called as difference, fg, which is the multiplication, will be called as product, right? And f over g will be called as quotient, just like the regular algebra. So, and also domains of the set of all real numbers common to the domains of f and g. Now the interesting question people might be asking you that how the domain will be changed. Now for an example, before you are adding f and g, let's say there is a domain of x, f, right? Meaning there is a set of domain set for f and there is a domain set for g. Now what happens after you add? What will be the domain? That might be an interesting question. Do you see this intersection symbol before? It's a reverse U. Do you see that? It's not union. That's called intersection between 2 domains. What does it mean? It means that when you are taking intersection, you'll be taking all the common points between 2. Only the common points. Now for an example, let me show you an intersection. Let me show an intersection, or maybe just wait a minute. Let's look at a couple of operations, then we'll talk about this intersection. Just for now, just know this, that whenever you will be doing those kind of operations, any of those 4 operations, your domain will be ultimate domain, because since you are coming up with a new function after addition or subtraction or division or multiplication, your domain will be the union of 2 original domains. Now, for an example here, we are just trying to show you that what happens when you are dividing. For an example, let's say you are taking f and g. Your f is x squared minus 4 and g is x minus 2. Okay. Now, you are dividing f and g. So, what do? You x squared minus 4 and x minus 2. You know that x squared minus 4 can be written as x minus 2 times x plus 2, right? Do you know it? There is a formula, a square minus b square. Have you ever heard about the formula? So let's see, a square minus b square can be written as a plus b times a minus b. If you compare this here, x square minus 4 is basically x square minus 2 square, right? Now it can be compared with a square minus b square. X minus 2, that's what exactly we did here. It doesn't matter which order you follow, but you know, you're writing x plus 2 and x minus 2.
Now once we have it, you can cancel out, because we did that because we wanted to cancel x minus 2 and x minus 2 at the top and bottom, and then we end up with x plus 2, right? Now, the interesting part is,
what will be the domain of f and g? That might be an interesting question. What might be the domain? So here for, let's see, we know that after the division we do not have 8, but one of the things that you must know, look at the first line. If you are doing a quotient, determine the domain before simplifying, because after the simplification some of the terms are gone, right? But you have to decide the domain before the simplification. Now let's say you are not done with the simplification. At this point you have x minus 2 at the bottom, right? Now that is a problem, because when you have something in the bottom and that has an x term, there is a chance that that might be 0, right? And when the x minus 2 can be 0? Whenever x will be 2, right? Whenever x will be 2, x minus 2 will be 0, right? And that exactly for that reason we exclude 2 from the domain set. Look at this. We are just saying that we will take everything except 2, right? This is what we did. We are taking from negative infinity to 2, but the 2 is not included. We know that, right? The 2 is not included. And we are again taking everything just right after 2, from 2 to positive infinity. And that's one of the reasons we want to make sure that we know that. We can, after, when we are calculating the quotient, we'll just simplify something, and after simplification it's possible that there is nothing at the bottom. I'm saying at the denominator, okay? But we just want to make sure that the domain is decided before the simplification, because after the simplification some of the terms may be gone. But that is not true in case of x equals to 2, because what happens in real situation, when x equals to 2, this will be 0, right? And this will be 0, so the whole thing will be 0 as well. So it becomes 0 by 0. We don't know exactly what is 0 by 0. It's not defined in mathematics. 0 by 0 is undefined. So still you cannot take 2. You know what I'm saying? X cannot be 2. So that's why, but after simplification, that x minus 2 term is gone. So that's why we still want to make sure that we understand that the domain has to be calculated before the simplification. Okay? That's one of the critical points we want to make sure. Alright, so determining domains when adding and subtracting. Alright, here two functions, f of x and f of g. We just added them. Now after addition, this is going to be a simple thing, right? Now how about their domains? Remember, as I said, we only take the common points, but we probably did not explore it yet. Look at the common. What do you mean by common points? Now let's say for f of x, if we have to determine the domain for f of x, what do? You just make sure that x plus 3 is always greater than equals to 0, right? Because it cannot be negative. It will be undefined. So we just make x plus 3 greater than 0, and we know that x has to be greater than negative 3. So based on that understanding, we draw this blue line. So this is going to be the domain. So starting from negative 3 to all the way to the positive side, that is the domain of f, right? So this is the part of the x-axis. Probably the y-axis is somewhere here. This is the negative side, right? So y-axis is probably here, let's say. So this is only the x-axis. So I'm just trying, because we are just talking about the axis, right? Domain is all about x. Now, how about for the g of x? We want to make sure that x minus 2 is always greater than equals to 0. From that we know that x must be greater than 2. Oh, so y-axis is probably here. This is 2, so it's here. Okay, now, so we have drawn the. When you are combining these both situations, look at this. From here,
in the blue line, from negative 3 all the way to the infinity of 2, right? for the red line from 2 to all the way to infinity are true. But can you find one such range for which both of these are true? That is basically starting from here all the way to the infinity, right? But this part, look at this part. In this part, blue line is valid, but not the red line.
So that's why for the new function, I'm saying after the summation, the new domain is this. That is called intersection, because by intersection we mean we only take the common portion of the domain. Because you see here, starting from here to the end, this is the common portion, because here for every single point, blue and red, both points exist, right? But before this point, only the blue exists, but not the red. That means the intersection. Remember I said that whenever you do those operations, it doesn't matter whether you do the addition or subtraction or division or multiplication, we always take the common points. So this is an explanation of the common points. So we always take only those points which are valid for both of the functions, not for one, but not for the other, not those. We take all of those which is valid for both. So after 2, we have red line, we have blue line. Before 2, we have only blue line. But before even -3, we have nothing. So we just start from 2 to infinity. All right. So this is an example. They try to draw it. Just try to show that it's true for -2 to infinity, because you see the line is started from 2, -2, and it's going all the way to infinity. So when you are multiplying functions, how you, again, as we know, that we'll be always taking the domain, the common points as the domain, but still we want to make sure when you multiply two functions, you see this multiplication, right? It's just like you're multiplying these two. Now what happens? For the first function, what is your domain? Look at the first function. You always want to make sure that the denominator is not 0, right? So at this point, denominator is x. So you always want to make sure that x is not 0. Everything else, okay. The only point you cannot take is what? 0. Only point of x which is excluded is 0. Everything else, okay. So here is our, let's say, the blue line. We excluded the 0. Do you see we are excluding the 0? This means exclusion, right? Okay. Now, for the g part, we want to make sure that x minus 2 is not 0. By that we know that basically x cannot be 2. So we excluded 2. Now, when you combine these two by multiplying, we want to make sure that both of these points are excluded. Because in this point, first function is not valid, but the second function is okay, right? But in this point, second function is valid, but second function is invalid, but the first function is okay. But remember, as I said, we want to make sure we want to take all the points where both of the functions are valid, not one. So that's why we will exclude both of the points, because we know that in both of these points, one function is valid, other function is not. Right? So, how do you write it? We will take all the points except 0 and 2. Look at this, how we wrote. We are taking everything from -infinity to 0, but 0 is not included. Again, we started from 0. We have taken all the way from 0 to 2, but 2 is excluded. And we again started from 2, not including 2. We started from 2 all the way to infinity. So we just excluded 0 and 2. It's important to understand that how, because we can simply do the multiplication, summation, addition, or subtraction. But it's more important to understand that how we can find the domains. Okay, how the domains are changed. Whether any question here?
All right, so here are some examples of, let's see, so I think we can do this. Let us try this, because we are more interested about the domain. Because I know that we all can do addition, subtraction, multiplication, division, but most of the important part is, can we find their domains? Let's see which one is more interesting. I think the second one will be more, yeah, this will be also great. But let's try this. So, we have one function which is f of 1x. F of x equals to 1 over x. The next one is 1 over 2x minus 1. Now, here, we were asking you to find their domains. Remember, you don't have to multiply and division to find the domain. All you need is, you have to find the domain of each of those and then take the intersection, right, of both of the domain to come up with the ultimate domain of the product or the quotient function. All right, so what is the domain for f of x? So the f of x is 1 over x, right? What is the domain? X cannot be 0, right? That's the only thing we know. X cannot be 0. Everything else is okay. So let's draw the line for x, axis. So let's say this is 0. This is excluded. Okay. Let's draw the lines like 1, 2, 3, negative 1, negative 2, negative 3. Okay. Now what else is, okay, now let's check the g of x. We know that 2x minus 1 cannot be 0. So let's make it 0 and then we'll exclude that point. Let's make it 0. So what will be x? X will be half, right? So half is probably here, right? So let's exclude. So 0 and half, both of the point will be excluded in your answer. Any doubt here? This is half, right? Everybody has the same answer? Okay. Now let's try to write the domain here. Starting from 0 to, starting from negative infinity to 0, and then we did not include 0. We again start just right after 0 to half, and then we include everything from. So look at this carefully. Here? No. We are saying that we cannot, this part will not be 0. Okay. But what we are writing is equal to 0, because we want to make sure, we want to see what is the value of x for which this equation becomes 0. We know that this is half. That means these will be excluded. You know, to be simple, if you want to think this way, you can make it not equal. But I was just following the convention of the book. But it's up to you. It's again the same thing, because what we are saying is this point will not be excluded. That means we just want to make sure, we just want to see that if it is 0, what will be the value of x? And we know that for sure that will be excluded. And that's what exactly we did. Once we know that that is equal half, we excluded that point. And we wrote the domain excluding 0 and half. Those are the 2 points which cannot be considered for the domain. Any question? Because for those 2 values, either of the function will become undefined. Now when you are combining them, if one function is undefined, whole function will be undefined, because you combine by addition, by multiplication or quotient.
Okay, how about here? Square root. All right, here, okay, just to make sure that x minus 1 is greater than equal to 0. So x minus 1 greater than equal to 0 means x greater than equals to 1, right? So let's say we draw a blue line for an example for this. So which is, let's say this is our blue line. So this is our 1. Let's say this is the blue line. So let's draw the x-axis. This is our 1. This is 0. Let's say this is negative 1. Now, for the other one, for the g of x, as you can realize that x must be greater than what? 6, right? 6 or more. Because anything less than 6 will give you a negative number, right? So let's draw a red line for that. Let's see, it's 1, 2, 3, 4, 5, 6. Let's say this is your 6. So the your red line will start from here, including this point, all the way to infinity. Now, when you combine both of those functions, you will definitely make sure that you will take the domain for which both of the functions are true. Now you look at carefully that after 6, both of the line will exist, right? Because this line will continue all the way to infinity, right? So after this point, both of the line exist. But before this, one exists, other not. Before even 1, none of this line exists, right? So valid starting point is 6. So your domain should start from 6 all the way to infinity, including 6. Because you can include 6, because whenever you include 6, you'll get 0, and which is okay, right? So the domain will be 6, starting from 6, including 6 to all the way to infinity. Okay. Any question? All right, so let's try. Oh, what is the question? This one and this one. Okay, I think we discussed it sometime. Just to make sure that we again, I think some of you still have some question. Whenever you include that point, use this bracket because you are including 6. Whenever you are, for an example, if I start with this bracket, that means we are starting just right after 6, but the 6 is not included. Now we know that the 6 is included because remember the other function will be this, right? What does it mean? X equals 6 or greater than 6. That means x can be 6 or more. It can be included. You see what I'm saying? Yes. Yeah. When it is included, you get the bracket. When it is
Excluded, you just
one. Yeah, we wrote that. We see, we have drawn that. We have drawn these two. But what happens is, since you are combining both functions, because you are subtracting, and after the subtraction of both functions, you will end up with another new function. And now we want to make sure that the new function, the domain of new function, is basically valid for where both of the line exist. But look at this. This line starts from here, right? This is your blue line, and this is your red line. So, but we want to make sure that we start from a point. After that point, both of the line exist. Because look at this. After this point, both of the lines exist. But here, none of the line exists. I'm sorry, only one of the line exists. But before one, none of those exist. So that's why we start from here. And if you start from here, what do you say? 6 up to infinity, including 6. You can include 6 because of this, because it's x equals 6 or more. In some cases, remember in the other one, previous one,
sometimes we cannot include that point, right? So, and then we write the parenthesis. Now we give the bracket because we can include that point. 6 is included, everything else after that 6 is included as well. Okay, because we sometimes define the function that way, because can you basically tell me what is the point just right after 6? You cannot, because those are real points and there are infinite number of points. You cannot even write that. Can you write it? What is the point just right after 6? You cannot write that. So that's why sometimes instead of writing, this is like a better formulation of explaining that, okay, just right after 6 but not 6, because you cannot write that since this is a real plane. Any question? Okay, now composite function is another operation of functions, but it's not basically the regular operations we do. So it's an interesting one. Look at the composite operator. That's a small bubble, okay? F small bubble g. What does it mean? It means f of g of x. It's a little bit tricky. What does it mean? F of g of x. Now, we'll do that for sure. Now here, just before we do some example, we are just trying to read how, when we see this, how we read this. So we read this equation as f of g of x. Okay, because f of g of x, because g of x is already there, and this is called a composite function. Now let's see how we do this. I think that will be a better example or understanding of that. We'll come back here. Let's do some composite operation first, and then we'll talk about the domain. Let's do it first. Now let's say we are given one f of x, and we are given g of x. Can we find f composite gx? Now what is f composite gx? It's nothing but f of g of x. Now what is that? Let me write it down first and see whether we can solve this composite function. So f composite g of x. This means f of g of x. Okay. Now let's try to see what does it mean. Now let's write g of x here. What is g of x? I'm just copying from there, right? Now, can you do this? What we are saying is, can you replace x? Can you replace x by 2 over x in f of x? What is your f of x? Let me write f of x here. Look at this. This was your f of x originally, right? This was the original f of x. Look at the question. Okay? Now by this, what do you mean? Replace the x by 2 over x. So this was the x, right? Replace it by I think we can do this, right? Can we solve it? Yes, no? Composite function. Now, to solve it, what do? Let's say you want to get rid of this x.
How can you do this? Multiple options, but one option is you can multiply both numerator and denominator by x. So then you can get rid of this x. So let's try that. So you are multiplying x times 3 and x times here 2 over x minus 4, right? Then you will get 3x here, 3 times x, and when you will multiply this, x and x will be cancelled, so this will be 2, and this is going to be 4x. This looks a little bit nice right now, right? It's still the same thing, but we just wrote the same function. So this is probably the composite function of
f of g of x. So think about it from the beginning. Think about this from the beginning. F of g of x. What do we did? We just first replaced the g of x by the function g of x, right, which is 2 over x, and then we replace x by 2 over x in f of x. Because this is how we, remember we did this before, right? Let's say we given f of x, we try to find what is f of x minus 2. What we did? We replace x by x minus 2. We are doing the same thing. We're replacing x by 2 over x, or however the function is defined. Now here, this is an interesting slide, that excluding values from the domain of this. Now the following values must be excluded from the input x. If x is not in the domain of g, it must not be in the domain of f of g of x. If x for which g of x is not in the domain of f must not be included here. Now let me come back to the rule, what it is. Let's say here we have an example. This is your f of x and this is your g of x. We are looking at this example. This is pretty much close to what we did here, not exactly the same thing. But looking at this one, once we understand it, we'll be able to find the domain here. So what we did is, similarly, we just tried to solve this equation just the way we did. So we try to solve, and after that we have that. Now instead of just applying 3 over x, they applied g of x here. Now what we did is, we must exclude the points from the domain of f of g of x, any x for which g of x equals to 1. Now what does it mean? Why they are talking about these? Because look at this, what they did. They replaced the x by g of x, right? We exactly did that. This is g of x, right? We're replacing the x by g of x. Now here, what happens if the g of x equals to 1? It will be undefined, right? Look at this. If g of x equals to 1, this becomes 1 minus 1. And it will be 0. We cannot tolerate that, right? Because we do not have a division by 0. We cannot have that. So that's why we wanted to make sure that this cannot be, these do not. So that's why we just assume that g of x equals to 1, because we are trying to exclude that point for which g of x equals to 1, and this is g of x. And for that we got x equals to 3. So we know that 3 must be excluded. And just look at this, what we did. We excluded the 3, and also, so we excluded the 3, and also we excluded 0. Why you excluded 0? Because look at the g of x. Can we take x equals to 0? No, right? So there are two spots. So let's do the example, the one that we did. Let's do this and see whether we can understand how to find the domain here. Let's do it again. Let's try to find the domain again for this problem. Now, first of all, here, 2 steps. First step, we will look at g of x, straight g of x. This is our g of x here, right? This is the step number 1. We'll look at g of x. If we see, okay, now, so x cannot be 0. This point is excluded. That's the part 1.
In the part 2, whenever we find that f of g of x, what does it mean? What does it mean? It means that we write the function like this. I'm sorry, 3 over
do you agree with this? What do we do? Look at this. We are replacing the x by g of x. Right? Look at the original function. F of x equals to 3 over x minus 4. We just wrote the same thing, but we replaced x by g of x because we are doing we are replacing x by g of x. Now, what do you want to make sure here? You want to make sure that this term, this whole term, do not get 0, right? Because it becomes 0, the whole thing will be undefined. So g of x minus 4 cannot be 0. So let's write it down. G of x minus 4 equal to 0 because we want to exclude that point. That means what? So this is one point and this is the other point are to be excluded, right? Because for both of these points, your function will be undefined. So you always will have 2 points. One will be coming from g of x, one will be coming from the composite function after you do the composition. And then you will be able to write the domain. Why did not I plug in what?
Why don't you do 2 over x minus 4 equals 0, and then x equals 1?
See, there are 2 different things. Because at this point, one is we do not want this whole thing to be 0.
Right.
For that, we don't want g of x to be 4. Okay? Now, let's check. G of x, okay, wait. He was right. Because we want to find the x. You are right. Because this is only g of x, but we are looking for the point x, right? So we will plug in this value. After that, we'll get x. So we did not have the x here. So what is x from here? Half. Everyone see that is half? How do you know? I'm saying, how do you get that? We know this is half for sure, but I'm just trying to know that what step you do. You multiply both sides by x. That how you get? Okay. Let's multiply both sides by x, then you will get 2 equal to 4x, and then divide by both sides by 4, you will get x equals to half. So 2 points. Okay, so one is this. Let me erase that. One is half and one is 0. These 2 points are to be excluded. From the domain of f of g, so that we don't have any division by 0. Now can you write the domain after this exclusion? We are excluding 0 and we are excluding 2. So how you write? Negative infinity to 0. Look at this. 0 is not included. Oh, union 0 to half. Union half to positive infinity. Okay, so we have 2 points of x, one is 0 and one is half, which are to be included so that we don't have any division by 0. You have question? Anyone has any question? Let's see what we get another example. Let's see where we are. See, some of the slide I sometimes skip some of the examples, but when you browse it, see whether you can do the same example. Because when I see some of the, sometimes we have like multiple examples. We choose only 1 or 2. Maybe we choose. Okay, now how to decompose the function. Now so far we did the decomposition. Now what does it mean by decomposition? Now what we did in the composition? In composition,
we wrote 2 functions as 1, right? Remember, we wrote g of x and f of x as only one function, f of g of x. In decomposition, what we are going to do is we are going to
write one function into two. Okay. Now here, can you write this function as the composition of two other functions? One of the simplest steps is this. Just assume that whole thing, assume the x square minus 3x plus 2 as another function, g of x, and then you know that so you can assume that this is a new function, okay, and then just write f of x equals to square root of x, because that was your original, that is another function, and h of x, which is a composite function, is f of g of x. Okay, so some of those should be extremely simple. So what we are doing is we are just taking that g of x as x square minus 3x plus 2. Okay, so let me give you a quick clue that how we write f of x. Some of you probably is a little bit confused about f of x, how we do that. So let's see. So here we are first writing h of x. We first have h of x equals to x square minus 3x plus 2. Now we assume this is g of x. So we just write g of x first. Now to write f of x, what we do is we just write, instead of h of x, we write f of x. In the right side we still take the square root, but instead of this we should have written g of x, but we just write x, because when you do the composition, what happens? You replace this x by g of x, right? Think about the composition. What do? In the composition you do this, and then this x will be replaced by g of x, right? That's exactly how we are thinking right now. We are just replacing the g of x by x. I'm just trying to show you the comparison, that what we did. Okay, so that's why we at this point we just write x, because we know that during the composition this x will be replaced by g of x. Because anytime you are doing decomposition, that means somebody can do the composition and get the reverse answer. It's basically the reverse process. When you do the composition, what do you get? You decompose, you just get the reverse version. Okay, or you do some kind of decomposition, you should get that answer, composite answer, when you do the composition. Okay, so that's exactly what we are doing. So but can you try this? How about g of x equals to x square minus 6x plus 5, right? If you assume that g of x equal to 6x square minus 6x plus 5, what will be f of x? X to the power 4. It should be g of x to the power 4, but you know that should be there when you do the composition. So let's do it in the other side. So what we are doing is here, g of x equals to x square minus 6x plus 5. If we do this, f of x is going to be x to the power 4. Just assume that this x is your g of x. Then everything will be okay, because you know when you do the composition, you will be basically replacing this x by g of x. So it's pretty much the same thing. Any question here? One more example. Just can you quickly tell me what will be g of x here? 9x square minus 64, maybe g of x, right? Yeah. So again,
these are some examples.
So let's see whether we can pick something from here. Which one we can pick? Is this, let's see, the domain.
Let's pick the last one, because we're still interested about the domain, because that's the most important and critical question of this section. We are given f of x and g of x. Can we find the domain for the composite function? Remember, in case of composite function, we first look at g of x only. Okay? Do you think for g of x, is there any risk, or is there any point of x which cannot be taken? Look at g of x. Do you see any points of x for which g of x can be undefined? No, right? Look at g of x. It's pretty simple, 4 minus 3x. So there is no risk of division by 0, and there is no risk of the square root of negative number, right? Because there is no square root, and there is nothing divided by x, right? So for g of x, it's pretty simple. All the points are included. So we don't care about g of x at this point for this problem. Now how about f of g of x? That might be a trouble, right? Let's look at f of g of x and see what happens. When you do f of g of x, because you are doing composite function, so what you will have is, this is going to be g of x, because you are replacing x by g of x, right? Now what do you want to make sure? You want to make sure that this part here is always equal to 0 or greater. It cannot be negative, right? If it is negative, then it will be undefined. I'm saying you will get a complex number, okay, not real number. So g of x minus 4 has to be greater or equal to 0. That means what? Let's write g of x here. G of x equals to 4 minus 3x minus 4, right? I just wrote g of x from there. Now 4 and 4 can be cancelled. So you have negative 3x. This is an interesting problem, because I wanted to tell you this. I thought I'll forget, but now we have an example. Now remember, I said that this is still an equation, even if you don't have an equality sign, because the equation can have an inequality like this. When you have an inequality, most of the operations are same except one, where you divide or multiply both sides by negative numbers. At this point, look at this. To get rid of this negative 3, you have to divide both sides by negative 3, right? Now what happens if you divide both sides by negative 3? Look at this, what happens. We know that we have to divide by negative 3. We are dividing. There is no meaning of dividing 0, because it will be still 0, right? You will divide for sure, but that will be still 0. But what happens if you divide or multiply by negative numbers, your sign get flipped. Do you see the flip? Remember that point, okay? When you have an equation with inequality, it will be always like that. If you do some kind of division or multiplication with negative numbers, which is negative 3 here, it gets flipped. So now you have x smaller than equal to 0. I think you already know it, but just to make sure, if you have not seen it before. What does it mean? This means that we can take 0 and everything less than 0.
right? So what will be the domain then? So the domain is going to be starting from negative infinity all the way to 0, where 0 is included. 0, right? Because all of the points included up to 0. Because if you have anything more than 0, this will be square root of negative number. So here this is a multiple choice question. So the right answer is D, the last one. Any question? Do you want to try these? Other example? You can try this one. This is again, or let's see, maybe the earlier one than this was. Maybe we can try this. This is going to be more exciting because we are still interested about the domain. So we have a function here, and this is just one function, nothing composite or nothing. And can we find the domain for this function? Now what do you want to make sure? You want to make sure that the denominator is not equal to 0, right? Which is x square minus 6x minus 7. It cannot be 0. So to know that, you have to solve the equation. What equation? X square minus 6x minus 7 equal to 0. Make it an equation first, and then solve the equation. We know the formula, right, to solve the equation. The first equation we did today, which was there? Let's write the equation here, which is x square minus 6x minus 7 equal to 0. If we try to solve it, what is the formula? Minus b. What is b here? This is b, right? Minus 6. So this is minus 6 plus minus square root b square minus 4a is 1, right? C is negative 7. 2a. Remember the formula, minus b plus minus b square minus 4ac divided by 2a. So we have 6 here plus minus square root 36 plus 28 divided by 2. Again 6 plus minus 64, 2, and then 6 plus minus 8, right? So you will have two solutions, right? One is 7 and the other one is negative 1, right? When you do the addition, it's 14 by 2, 7. Subtraction, negative 2 by 2, negative 1. Now these are the 2 points which must be excluded, because you cannot take these 2 points, because for these 2 points this expression will be 0. If this expression becomes 0, that function will be undefined, because the denominator cannot be 0, right? So when you exclude these 2 points, how do you write your domain? Starting from negative infinity to negative 1, but not including the negative 1, union negative 1 to 7, not including the negative 1 and 7, union 7 to positive infinity. So the right answer should be which one? Yeah, right answer is first one, A, right? All right. Any question? So tonight we have the deadline for section 1.5. We know that, right? We extended the deadline, but so tonight midnight is the question. Okay, yeah. Let me just a second.